Hey folks, I got a couple more examples of impulse and momentum. Two examples on this one to be exact. The first one I've got written out here. Let's say I give you a force that varies with time now. It's equal to 4t squared. And I want to know what change in momentum does that force create on an object between 2 and 4 seconds. Okay. So by the way, it doesn't matter what the object is. What matters is the force is 4t squared. Okay. All right, so since this force isn't constant, I have to do integration here. So I'm asking for delta P, which is delta mv, but I don't know either of those. But I also know that delta P is impulse. And the integral version of that is the integral of force dt. So that's what we're going to use here to find the change in momentum. We're going to use integral of f dt. So we're integrating, our time goes from 2 to 4 seconds, and our force is 4t squared, and then dt. And if you integrate 4t squared, you get 4t cubed over 3, and I have to evaluate that from 2 to 4 seconds. So I'll put the 4/3 out front here. You're doing 4 cubed minus 2 cubed. So this is 4/3 of 64 minus 8, which is 56. And 4/3 of that ends up being 74 and 2/3. And then the units, it's impulse, so it should be Newton seconds, but remember, equivalent to that is kilogram meters per second. So you could technically write either of those down. So that's the impulse imparted to the object. Now to find let's say you want to know the object's change in velocity, well, I'd have to know its mass in order to do that. Then you can do that. Now, I want to make a very important note on this integral and some confusion that happens. And this will happen on a question at some point during one of your tests. Okay, so we asked you for impulse on this question, and we gave you force as a function of time. What if I gave you the same force and I asked you for the work done between 2 and 4 seconds? So I'm not asking you for impulse this time, I'm asking you for work done. Well, here's a common mistake that students will make. They'll write work. Now, work is supposed to be the integral of force dr, or dx, or whatever dimension you're looking at. And then students will write in the integral, they'll write 4t squared, and then they'll somehow, dr will just kind of fly away or something like that, it'll just kind of go away. And then, sometimes students will actually put the times in here when those are supposed to be the starting and the final positions, but they'll put the times in there and they'll get an answer, and it won't make any sense because they've either found impulse or they have found some weird thing that doesn't make any sense at all. So what I'm trying to get at is the following. If you're trying to find impulse, your equation is integral f dt. If you're trying to find work, your equation is f dot dr. In other words, if you're finding impulse, your force has to be some function of time, which is what I gave you in this problem. If you're trying to find work, your force has to be some function of a position, of x or y or r or whatever, okay? Please don't confuse the two. So in a problem like this, if I were to ask you for work done between 2 and 4 seconds, you'd have to find some other way to figure that out, like, work is change in kinetic energy or something to that effect. They'd have to give you some other information in the problem besides what I've given you here. So be careful and don't make that mistake. All right, the other example I have for you is if we're live, this is a challenge problem I'll give to my students. So let's say we've got a balance. So balance has two pans, and it's balanced like so. Okay, pans are lightweight and doesn't matter because they're equal. And you're gonna fire a marble shooter at the far pan like so. And the marbles are gonna bounce off the pan at the same, and they're gonna bounce such that, let's say it's like an elastic collision. So they're gonna bounce off at the same speed they hit the pan with. And the angles will be, like if this is something degree, it's the same degree there, okay? So you got marbles bouncing off a pan, okay? Now, if you do that, that right-hand pan is going to go flying down, okay? So let me give you some data. Let's say you're shooting the marbles horizontally at 10 meters per second. They're shooting from a height of 2 meters above the pan. So this height right here is 2 meters. Let's say the mass per ball is 70 grams. Okay, so they're like heavy marbles, okay, or maybe like light tennis balls. And the number of balls per second, we're going to call that n just to give it a letter. But let's say you're shooting 10 balls per second. Okay. Now, here's the question. What mass can I put on the left-hand pan such that this balance will remain roughly stationary? So what's m? Now, the pan's not going to remain completely stationary. It's going to bounce up and down 10 times per second. But what mass can I put up here to keep the pans roughly level with each other the entire time? It's kind of jiggling up and down, okay? All right, now normally at this point, I would say stop, and I would have the students try this, okay? So try it. Pause the video for a minute or two and try it out. Did you try it? Did you? All right, so here's how to solve this. Okay, so we're going to use impulse, which is Ft. Okay, equals change in momentum. Okay, and what I'm trying to do is find the force that these marbles are exerting, the downward force these marbles are exerting on the right-hand pan. And I want to match that with the downward force that the mass causes on the left-hand pan. Okay, so I got to solve for F. Okay, so F is going to equal delta mv over t. Okay, well, m over t, that's the number of marbles I'm shooting per minute times the mass per marble or per ball. So if you take mass per ball times balls per second, you get mass per second. That's m over t. But the other thing I need is what velocity, what's the change in velocity of the marbles as they hit the pan? And here's where people get confused. The horizontal velocity of the marbles does not change anywhere in this situation. While they're flying toward the pan, Vx stays constant, it's a projectile. And when they leave the pan, it's the same Vx. They're bouncing off at the same speed with the same angle. So this 10 meters per second, you never use it. All right, you don't use it at all. It doesn't change. Okay. What does change is the vertical velocity of the marbles when they bounce. Right before they bounce, they're going down. Right after they bounce, they're going up. Okay, so that's a change. Okay, so we're going to find this downward velocity and then double it. That will be our change in velocity. If you're going down at 3 and then you're going up at 3, it's a change of 6. Okay, so similar, we're going to get similar numbers. So for that, I just used V final squared equals V naught squared plus 2a delta y. Now remember, this is in the y direction. Okay, this is in the y direction. So Vx doesn't go in here anywhere. V final, we're trying to find that. That's the velocity with which they're hitting the pan. V naught in the y direction is 0. They start off horizontally. They ain't moving vertically when they leave the little marble shooter. And then we got 2, and this is g, and this is h. So V final equals root 2gh. And if you plug your numbers in, h being 2 meters, I got about 6.26. The delta V, we have to double that because the marbles are moving downward when they hit the pan, and they're moving upward at that speed when they leave the pan. So delta V is approximately 12.52 meters per second. That's what's going to go in there, okay? So we have our force. Force is going to be the mass over time, which is 70 grams, that's 0.07 kilograms, times 10 of those each second, okay, times this change in velocity, which is 12.52, and that's your force that you have to balance, which I get, when I plug those numbers in, I get 8.76 newtons. So to find the mass on the other side, I just set that, 8.76 newtons equal to mass times gravity. And I get a mass of 0.894 kilograms, or 894 grams. So if I put 894 grams over there in that left-hand pan, the pan, while it'll jiggle, it won't move up or down significantly. So again, on these kind of problems, what you want to think about is what's changing and what's not. So like in this problem, Vx didn't change, so I ignore it. Vy is the one that does the changing, so that's the one I need to put in here. All right, I hope those two examples were helpful, and thank you very much.